Hi folks, I'm Kelly Kohlleffel with Fivetran. I'm going to show you today how to build a powerful RAG-based Gen AI application with structured data. The project today is a California wine country visit assistant, which we'll create using the latest tech stack from Fivetran and Google Cloud, including the Fivetran Data Movement Platform, Google BigQuery, Vertex AI, and Gemini. This demo is from a hands-on lab that we ran recently together that everyone really enjoyed. I have to mention this project was made possible by the tremendous partnership and work of the Google Cloud team, including Bruce, Z, Juan, and Dibya. It is an absolute pleasure partnering with each one of you. For this RAG application, we're using a custom private data set stored in a structured format in a relational database. The structured data set has over 700 wineries across all of California's diverse wine regions. By the end of the demo, we'll have a functional AI assistant that can help plan wine country visits, provide detailed information about wineries, and even create personalized itineraries. So let's get rolling. I normally don't create a new destination in demos, but I will today. Fivetran and Google Cloud make it really easy. Just select your destination out of the cloud data platforms, data lakes, and databases that Fivetran has available, name it, and add your Google Cloud project ID. From there, it's really simple to add the Fivetran service account associated with your new destination to your project. Take the service account ID in the setup form and in Google Cloud IAM, add that Fivetran service account as a principal and grant it the BigQuery user role. You're done. I'll hop back over to the Fivetran setup form. Once you select your Google Cloud region, hit save and test, and Fivetran will run through the BigQuery connection testing sequence for you. There's the BigQuery destination ready to go, and now it's time to add a new connector and get data moving into BigQuery. Out of the 650 plus sources that Fivetran has available out of the box, I want to connect to Google Cloud PostgreSQL, which is where I have the California wine country data set that we're going to use today. I have 4 destinations in this account. I'll use the new RAG_Gen AI destination that I just set up. I mention this a lot, but it's worth repeating. Since Fivetran handles all schema creation and ongoing management and table maintenance, there's absolutely no need to create schemas or tables ahead of time in BigQuery. Provide a unique name for the connector and the other credentials needed to authenticate to the Postgres source. I have multiple options based on how I want to connect and multiple options on how I want to pick up changes in the Postgres source. I'm going to select teleport as my change detection mechanism. I'm also going to choose my TLS certificate because that allows Fivetran to encrypt data in motion as it's moving from my source database all the way through to BigQuery. So Fivetran is going to run the rest of the checks, connect to the database, make sure everything looks good, and once I've finished those checks, and Fivetran will let me fetch the source schema associated with that Postgres industry database that we just selected. And as you can see, I've got, 13 schemas out there. I don't want all of those today, so I'll block everything, but I'm going to light up the agriculture schema and the California wine country visits table. I'm also going to give you a glimpse into a really cool private preview feature, row filtering, which allows you to choose a column to filter on and then further refine your data set if you like. I can also add hashing at the column level for any PII columns where I want additional data privacy and anonymization. Lastly, you choose how you want Fivetran to handle incremental sync changes in the source. And that's it. Start the initial sync, and while that's running, why don't we take a look at a few options for this connector. I can set my incremental sync frequency anywhere between 1 minute and 24 hours to go out and capture changes from my Postgres source in order to keep my Gen AI app always using the freshest data as my source changes. I can also adjust schema change settings here and set my delay threshold. Okay, the initial sync's complete and the wine country data set has been moved to BigQuery, and my incremental sync has been automatically set up for me by Fivetran. Jump out to BigQuery. Here's the new schema, RAG, structured data, Fivetran agriculture, and the new table, California wine country visits that Fivetran moved. You can see that all the data is very usable, it's organized, it's understandable. I'm going to be using Google BigQuery with Vertex AI and Gradio for the application environment. Before Gradio can interact with the Gemini LLM for responding to my wine country prompts, there are a few configuration steps needed to allow the application to interact with Gemini. So BigQuery Studio supports Linux commands, Python code, or BigQuery SQL commands. It's going to be perfect for our use case. I'll name my first notebook BigQuery Config, and I'm going to quickly step you through the code blocks associated with the notebook. Code block 1, I'm going to set my project ID as a variable. Code block 2, I'm going to authorize access to other Google Cloud resources within BigQuery, such as Vertex AI. You'll hear about why a little bit later on. In number 3, I'm going to retrieve the service account for my cloud resource connection. And then in code block 4, I assign the AI platform user role to my service account in order to access Vertex AI services. In number 5, we create a travel assistant data set. In code block 6, we create a new model in that new data set to register a Vertex AI endpoint as a remote model in order to call it from BigQuery. Code block 7 is really interesting. A couple of things going on. Number 1, transforming the structured data, 28 columns or so, to unstructured format using the concat function, essentially making the data set LLM-friendly. Instead of 28 columns, I've got a single string per row or per winery. Secondly, I'm calling a Vertex AI text embedding function to generate the vector embeddings for the data set. That's going to be really important later on. In code block 8, it's nice to take a look at the output of the LLM transformations, and here it is. You see the content, which is that unstructured doc or the single string that was created from 27 columns of structured data per row, and you see the text embeddings. So we have that. Now it's time to put this transformed data to use, this LLM-friendly data to use. Let's go build the wine country travel assistant in Gradio. If you've not used Gradio before, it's an open source Python package for quickly building a UI that can be embedded in either a Python notebook or presented as a web page. We'll do both today and use the web page more so. I'll open up a new BigQuery Python notebook and call this one Wine Country App. Here are the high points for this notebook by code block. So first we'll install dependencies, including Gradio. Second code block restarts to make future code block access a little bit smoother. Code block 3 loads the Python, BigQuery, and Vertex AI modules required for the application. In code block 4, we have some customizable user parameters. The only thing I updated here was my project ID, my Google Cloud project ID. In code block 5, this is a core part of the app. It uses the vector search and text embedding functions. It sets the context for formulating answers to prompts, and it interacts with the Gemini LLM for inference, and also tracks history. Code block 6, really interesting as well. It sets the system prompt, which explains to Gemini what we're trying to accomplish. Who are you, Gemini? You're a wine country expert. What's the history? What's the conversation we've been having? What's the context or the chunks which you're going to use to formulate the answer? And lastly, what's the question that was asked? What did I ask? What was the prompt that came from me, the user? Code block 7 is a checkpoint to make sure everything's working. Code block 8 is a quick query from the BQ table on a control record. Remember, there are 5 control records that only exist in the BQ table from the data that was moved into BQ from Postgres with Fivetran. Code block 9 is the Gradio chatbot app environment, which also produces a really nice gradio.live URL to start the Wine Country Visit Assistant in a new tab. All right, let's go. Time to have some fun. I'll run a few prompts with the control record. Kohlleffel Vineyards, I'll use that. My own vineyard. Wish I had one. I don't. Kohlleffel Vineyards only exist in the Postgres data set that was moved into BigQuery. I want to demonstrate the power of Retrieval Augmented Generation, or RAG, which combines your private, bespoke data with an LLM's previous knowledge, but in a very secure and governed way inside Google Cloud and BigQuery. All right, this is exactly who Kohlleffel Vineyards is in the data set. Established in 2024 on the Sonoma coast, offering Pinot and Chardonnay, the vineyard dog Arthur runs around on the property. You have a vintner path experience, wood-burning fire pits, an interactive Fivetran hands-on lab to build a RAG travel assistant application, all the things there that I know are in that data set. Very, very cool. Gemini did a fantastic job here. All right, let's get a little more detail here. I mentioned Arthur the vineyard dog, and in that data set, I'd mentioned a couple of Arthur's favorite things. He's actually my son Sam's dog, and he really enjoys chasing tennis balls and sausages. There you go. Yeah, if you can't tell already, this vineyard is really built around some of my favorite things. In addition to Arthur, I love wood-burning fire pits, Santa Maria grills, and I felt like at this vineyard I wanted to offer a variety of woods that guests could choose from. So you got post oak, red oak, hickory, mesquite, pecan. And of course, wine tasting can get old after a while. Other activities that I wanted to offer at the vineyard. This is all in the data set, by the way. You got kayak fishing, volleyball, basketball, tennis, and hiking trails. And then lastly, let's bring this all together. I'm looking for a travel itinerary that includes the RAG portion of this demo. Give me Kohlleffel Vineyards out of the data set, but include other things that are only known to the LLM on the training data set that LLM used. And so that's what this prompt is meant to do, bring it all together. What I get back outside of the detail on Kohlleffel Vineyards is coming from the LLM knowledge base, but it's even more useful now when I combine that with my private data to allow for better answers to my prompts, more customization, more relevancy, and more informed and accurate answers. So I'd encourage you to try out the Fivetran Data Movement Platform and Google Cloud together with BigQuery and Vertex AI with your data to build a RAG-based Gen AI application. Fivetran's automated, reliable, and scalable, which allows you to spend your time focused on building high-value data products and services, not worrying about data pipelines and data movement. I'm always interested in hearing from you on success you're having with Gen AI and RAG, either in development or production, and what you'd like to see profiled in the next video. Take care.